Hey guys, in this video we're going to take a look at the triangle inequality theorem and the relationships that triangles have between their sides and their angles. So to start off with, we're going to start with the triangle inequality theorem, and that tells us that in order for a triangle to exist, the sum of the two lengths of any two sides of a triangle has to be greater than the length of the third side. So if we have a triangle, and we're only talking about sides, I'm worried about sides, so I'm going to call these sides A, B, and C. A plus B has to be greater than C. So whatever those numbers are, added together, they've got to be greater than C. But those aren't the only two options that we could have for sides for the third side. We would also have to check B plus C and make sure that it's greater than A. And then we would also have to check A plus C and make sure that it's greater than B. And then we can also look at the angle-side relationships in a triangle. And what that does is tells us that there is a direct relationship between the sides and angles that are opposite of each other. So if we're looking at a triangle, and we'll go ABC for this one, angle A is opposite side BC. So if we were to look and go directly across from there, angle A is directly across from or opposite of BC. We can also do that for angle B. Angle B is opposite. If we look from angle B to the side that's directly across from it, that's going to be AC. And then we can also do angle C is opposite AB. So that takes care of the sides and angles and which one they're opposite from. So in addition to them being opposite of each other, the longest side is going to be opposite from the largest angle. And the smallest side is going to be opposite the smallest angle. So the one that's in the middle is opposite from the angle measure that's in the middle and the side length that's in the middle. So if we go and we try that out, an example of something that they could have you do is to list the sides and angles from smallest to largest. Now a lot of the times it will be smallest to largest, but sometimes they may switch it up and say largest to smallest. You'll just have to keep an eye on what they're asking and make sure you list them in the right order. So for this, they want a list of sides and angles. So if we're doing sides, we have three sides. So I made 3 blanks for the 3 sides to go on it, and then I'm going to have 3 angles. So looking at the information that they give us, they don't give us any information on the sides, but they do give us all the angles. Angle T is 65 degrees. Angle S is 53 degrees, and then angle U is 62 degrees. So we can put those really easily. We can put those angles from smallest to largest. So you find the smallest number. So smallest number is going to be 53. So they want the name of them. They don't want the measures, they want the names. So the name of the smallest angle is going to be angle S. The next one after that is going to be 62. And that'll be angle U, and then the one after that will be angle T. So once you get the list of angles, you can also, right after that, get the list of sides. So our smallest angle was S. Well, if our smallest angle is S, the side directly opposite of that is also going to be the smallest side. So the smallest side is going to be TU. And then the next one was angle U, and the side that's directly across from angle U is TS. And then the last one, 65, was the biggest angle T, and it is directly across from side US. So there's how, given angles, you can list the sides and angles from smallest to largest. But they won't always just give you the sides or just give you the angles. Sometimes they'll give you mixed information. So looking at this, they're still going to want the sides and the angles from least to smallest. So looking at this, they tell us that HI is 30, and then that JI is 94, and that angle I is 97. So I'm going to start with angles because 97 is bigger than 90 degrees. So that tells me that this triangle is obtuse. And when you have an obtuse triangle, you can only have one angle that's bigger than 90 degrees. So that tells me that this is going to be the biggest angle that we could have. So that tells me angle I is going to be the biggest angle. So then we have to decide between H and J, which one's going to be the smallest and which one's going to be the one in the middle. So if I'm looking, well, I need to know something about angle H. So I look for the side opposite of it. Well, if I look opposite of angle H, there's the side measure of 94. And then if I look opposite of J, there's the side measure of 30. So between those two, the side length 30 is smaller than the side length of 94. So that tells us that the angle opposite of the 30 has to be the smallest angle. So angle J is going to be the smallest, and then angle H is going to come next. And then from there we can get our sides. So we did angle J was the smallest, so the side opposite of that is HI. And then we did angle H comes next, so that's going to be JI. And then angle I comes last as the largest, and that's going to be JH. So looking at another one, they could also give us expressions to represent those angle measures. So this one's going to be W plus 45, this one is W plus 12, and this one is W plus 33. In order to be able to put the sides and angles in order from largest to smallest, we have to know what those values are. So just as a reminder, I'm going to write angles, and then I need 3 of them, and sides. So, well, they give us all of the interior measures of a triangle, and if we use our triangle sum theorem, we know that angle F plus angle H plus angle G is going to be equal to 180 degrees. So angle F is W plus 45 plus W plus 33 plus angle G is W plus 12 is going to be equal to 180. Add all of our like terms, so 3W plus 45 plus 33 plus 12 is 90, is going to be equal to 180. Subtract 90 from both sides, and 3W is going to be equal to 90. Divide both sides by 3, and W is going to be equal to 30. So now that we know W, we can take W and put it in for each of the angles. So we've got 30 plus 45 will give us 75, and then we've got 30 plus 33 is going to give us 63, and then 30 plus 12 is going to give us 42. So to double check and make sure we've done all of our math right, 75 plus 42 plus 63, yep, and it does give us 180. So these are the measures of our angles. So if we look, 42 is the smallest, so angle G is the smallest. Next comes 63, so angle H, and then last comes angle F. So now we just need to do the sides. G is opposite of FH. H is opposite of FG. And F is opposite of HG. So there's our list for that one. And then looking at the next one, here they give us an angle of 105 degrees, and there they give us a measure of 35. And they want to know the side lengths from least to greatest. So sides, there's 3 of them we need to list, and angles. And this is for triangle ABC. So that means we're only worried about the stuff on the inside of the triangle. Well, in order to be able to list sides or angles, we would have to know, at the very least, angles. So using our exterior angle theorem, I know that 105 minus 35 will give me this angle right here, so 70. And then this right here is a linear pair, and a linear pair is 180 degrees. So to get angle B, I did 105 is going to be equal to 35 plus angle B. Subtract 35 both sides. 70 is equal angle B. So now I'm doing a linear pair. So 105 plus angle ACB is going to be equal to 180. Subtract the 105 from both sides. And angle ACB is going to be equal to 75. So to double check the math, 35 plus 75 plus 70, yep, does give us 180. So now we just need to do the smallest to largest. So the smallest angle is going to be angle A, and the side opposite of that is CB. Now we only want the parts of the triangle, so that makes it be just CB. And then next comes angle B, and the side opposite of angle B is side AC. And then the last one is angle C, which is 75, and the side directly across from that is AB. They could also just give you the description of a triangle, and from that description just draw a picture. And for this one they just want the side lengths of the triangle, and they tell us we've got triangle EFG, and it doesn't matter what the triangle looks like as long as it's got 3 sides and you label the points, and whenever you label the points you make sure that you put the right values with the right point. So this is 31, angle E is 76, and angle G is 73. So it wants side length, so smallest to largest. Well, we've got to go with the smallest angle. Smallest angle is 31. It's opposite of EG. And then the next angle length is 73. 73 is opposite of EF. And then the last one is directly across from FG. So there's our length of side lengths from smallest to largest. They could also just give you a list of sides. So again, we're going to just draw a picture. This one's FGH. So they tell us FH is 69, GH is 71, FG is 48. And this one wants the angle measures. So we've got to find, it wants from smallest to largest, so we've got to find the smallest side. The smallest side is 48, and it's opposite of angle H. The next smallest side is 69, and it's opposite of, it's opposite of angle G. Side goes to an angle. So we've got angle G. and then the last side is going to be 71, and 71 is opposite of angle F. So there's our list of angles from smallest to largest given sides. But just like they did here where they gave you expressions to represent the angles, they could also do that with just a description. So just draw a picture with what you're working with. So we've got A, B, C, and A is 81U plus 20. C is 58U minus 22, and B is 24U plus 19. In order to be able to list the sides from smallest to largest, we would have to know the angles. So in order to find the angles, we need to use our triangle sum theorem and say angle A plus angle B plus angle C is going to be equal to 180 degrees. Angle A is 81U plus 20. Angle B is 24U plus 19. Angle C is 58U minus 22. And all those added up together are going to be equal to 180. So combine our like terms, 81 plus 24 plus 58 is 163U, and then combine our constant numbers, 20 plus 19 minus 22 is going to give us a positive 17, is going to be equal to 180. Subtract the 17 both sides, and 163U is going to be equal to 163. Divide both sides by 163, and then U is going to be equal to 1. So now we need to plug in U for each of the values. So we're going to have 24 times 1 plus 19 to give us 43, and then 81 times 1 plus 20. It's going to give us 101. And then 58 times 1 minus 22. It's going to give us 36. And if you double check and add them all up, they should be equal to 180. So this wants the side lengths from smallest to largest. So in order to list the side lengths, we have to find the smallest angle. The smallest angle out of all of these is going to be angle C. Angle C is opposite of side AB. So AB, and then next is 43. Angle B is opposite side AC. And then last is angle A, and angle A is opposite side of BC. So there's how to list them, given just expressions for angles for side lengths, smallest to largest. So now the next example they're looking at, can those side lengths make a triangle? So if we go back to our triangle inequality theorem, in order for a triangle to exist, the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. And notice we've got to check all three possible combinations for what we could have. So if we try that out, if this is A and this is B and this is C, and we've got to check out each of those, we've got to do A plus B has to be greater than C, and then B plus C has to be greater than A, and then A plus C has to be greater than B. So if we try this out, we're going to have 15.9 plus 13.6 would have to be greater than 0.5. and that's going to give us 29.5 would have to be greater than 0.5. And it can't be, so this can't make a triangle. So no, it's not a triangle. But what would happen if we tried the rest of them? Let's check. So B plus C greater than A. Our B value is 13.6 plus 0.5 would have to be greater than 15.9. So 13.6 plus 0.5 gives us 14.1. Is that one greater than 15.9? No, so another reason why it's not a triangle. Let's try the last one. AC plus A plus C greater than B. A is 15.9 plus 0.5 would have to be greater than 13.6. So 15.9 plus 0.5 gives us 16.4 greater than 13.6. So yes, that one works, but it's still not a triangle because in order for a triangle to exist, all three of these would have to be yes. So don't assume just because you get one yes, it's a triangle. You've got to try out all three. So our overall answer for this one, can the sides of the triangle have this length right here? The answer is no, it can't, because all three of these would have to be yes to be a triangle. Okay, let's try out the next one. So the next one, they give us 1.3, 5.9, and 4.6. So this is our A, that's our B, and then that's our C. So if we try them out, A plus B, so 1.3 plus 5.9 would have to be greater than 4.6. So 1.3 plus 5.9 gives us 7.2 greater than 4.6. Yes, that's true. So we might have a triangle. We have to have three of them in order for this to work. So we're going to do the next one, B plus C. So 5.9 plus 4.6 would have to be greater than 1.3. 5.9 plus 4.6 is 10.5. Greater than 1.3? Yes. So we've got 2 out of 3 of what we need to show in order to have a triangle. So the last one is going to be A plus C is greater than B. So we've got 1.3 plus 5.9. Is it greater than 4.6? Oops, this should be 4.6 and 1.3. There we go. 5.9. So 1.3 plus 4.6, is it greater than 5.9? So 1.3 plus 4.6 is going to give us 5.9. Is 5.9 greater than 5.9? No. This isn't an equal to, it's just a greater than, and 5.9 is not more than 5.9. So the answer for this one is no, it's not a triangle. So even though we had 2 yeses, just because of that one no, it's not a triangle. So looking at the last one. This is our A, this is our B, this is our C. So if we do A plus B first, we're going to have 4.7 plus 16.3 would have to be greater than 17.2. So if we try that out, 4.7 plus 16.3 is 21 greater than 17.2? Yes, it is. So let's try the next one. We've got B plus C. So 16.3 plus the C is 17.2. Is it greater than the A value? So 16, 17.2, 4.7. So obviously yes, but just to check, 16.3 plus 17.2 is going to give us 33.5. Is that greater than 4.7? Yes. So trying out the third one. The third one is A plus C greater than B. So 4.7 plus 17.2, is it going to be greater than 16.3? So if we add those up, 21.9 greater than 16.3, yes. So because we have 3 yeses, we can say yes, it is a triangle. And you've got to check all 3 different combinations in order to be able to tell for sure whether or not it is. So the next example, they could give you problems where they ask you what is the smallest possible length of the third side, or what is the largest possible length of the third side. And then they could also ask you to write a compound inequality. And all a compound inequality is it's a number less than a variable. In this case, we'll use x, which is less than another number. That's all they want it to look like. So a triangle has 2 side lengths for 8 and 12, right? What compound inequality decides the possible length for the third side? So if we're looking at a triangle, 18, 2, and x, we're still using that triangle inequality theorem that says you've got to add add 2 sides up to see if it's greater than the third side, and you've got to try all 3 different possibilities. The same thing happens here. So this is our A, this is our B, and then this is our C. So A plus B, to rewrite the rule, greater than C. In this case, we've got 18 plus 2 would have to be greater than x. 18 plus 2 is 20, greater than x. So x would have to be less than 20. And if you want to write it the other way around, you just take them and flip them. So it's like you pick it up and flip it kind of like a pancake. The inequality gets flipped too. So x goes over here, it becomes less than 20. So there's the first one. So our x values would have to be less than 20. And then if we try b plus c greater than a, our b value is 2 plus c is x greater than 18. Well, we want x all by itself on one side, so subtract 2 from both sides, and x would have to be greater than 16. And if we try the last one, a plus c is greater than b, a would have a value of 18 plus x would have to be greater than 2. So we subtract the 18 from both sides, and x would have to be greater than negative 16. And if we look at the values that we've gotten, we've got x could be 20. Well, that makes sense. Or x would have to be less than 20. That makes sense. We could have a measurement less than 20 here. X would have to be greater than 16. That makes sense. We could have a 16 here. But here we have x would have to be greater than a negative 16. So if we picked a value that was greater than negative 16, say negative 15, we couldn't put a negative 15 here because this side right here represents the length of the side of a triangle. And we can't have a negative length for a side. So whenever you get a negative value for this, mathematicians say that it's an extra solution that we're not going to use for this problem. So if we're writing it in the order that we have it, x, you put your smallest side on the left. We're making a number line is what we're doing. So you put the smallest number on the left, the largest number on the right, and then you put the inequality symbols in between. So if we have a triangle that has 2 side lengths of 18 and 2, the smallest side value that it could actually be, and I think in the practice problems they asked for the smallest whole number. This isn't an equal to. So the smallest whole number that it could be would be 17. And they could they could also ask for what is the largest And since the value of the side has to be between 16 and 20, our largest side can't be 20. It's got to be less than that. So our next largest whole number before 20 is 19. So 19 could be the largest whole number that it could be. 17 could be the smallest whole number that it could be. But if it asks you to write a compound inequality to describe the possible lengths, it's going to be 16 less than x less than 20. So these examples right here cover our triangle inequality theorem. And then the other examples that we've done show you how to use the triangle angle side relationships to be able to list the sides and angles from smallest to biggest or biggest to smallest. If you have any questions, make sure to write them down and ask when you get to class.